Hi students, I hope all of you are doing good. Okay, so this is part 2 of our Brainiacs intermediate revision series. So I have received good responses last time. Many students who visited this video, they were happy and they were giving me feedbacks and they were having their doubts, and I was able to solve it actually. Okay, so it's actually your encouragement that makes us to do more videos. So if you have any doubts, again I'm telling, please put it on the comment box. I'm here to answer you. Okay, so I hope you guys are doing well and all your preparations and everything, it is going in the right way. Okay, and you know that until now there is no notification came from the Medical Council of India regarding the syllabus. So we are in the plan like similar to NCERT. We are doing in the same chapters that are mentioned in the NCERT. Okay, and at the end of the day, and for example, once the important topics that is mentioned in NCERT are completed, then we can look for the skipped chapters. Okay, this is the main doubt many students are asking. Okay, so now let's go to the part 2. Here mainly we deal with stoichiometry related questions, and also we will do the empirical formula and molecular formula related questions that are in the chapter 1. Okay, that is basic concept of chemistry. So feel free to ask your doubt on the comment box. Okay, so you have the question in before you. So go through the question. So here the question states that, okay, let me say, in the following reaction, if the 10 gram of hydrogen reacts with the nitrogen, what will be the volume of ammonia produced at STP? So this is the question they have asked. Okay, so you might be knowing this is one of the famous equation. What is that? Haber's process, right? It is regarding the synthesis of ammonia. So we know what is that equation. Okay, so let us write the equation, then we will proceed. Okay, so the equation here is N2 plus 3H2 gives 2NH3. This is that equation. Okay, so it's a balanced equation. You can check it out. The number of nitrogen atoms are 2. Okay, and the number of hydrogen atoms are 6. Here also it is 6. Okay, and what is the steps? How to do this, sir? How to do this? So first I will explain the concept part of it I will explain, then we will try to do the question. Okay, so the concept part is very simple. So we need to first write the stoichiometric ratio. So I will put that chart actually. Okay, stoichiometry we need to write. Okay, stoichiometry we need to write. From that, what we need to do, then we need to see in the question with whom we need to relate it. So here hydrogen, they have given the mass and they are asking the volume of ammonia. So we need to relate between whom? Tell me, sir. Between hydrogen and ammonia. Between hydrogen and ammonia we need to relate. Okay, this is next thing. Now relate initially using stoichiometric ratio we need to relate. Then what we need to do? Convert that value to given value. So here given value is for hydrogen. So given value is for hydrogen. Okay, then check out. Okay, then calculate the volume of ammonia. Calculate the volume of ammonia. Okay, volume of ammonia. Okay, I hope it is clear. Now let's see how to do this. Okay, this is the concept map. We usually do it. Okay, so let us see. Now stoichiometric ratio, as you know, we can put it as SR. Okay, the stoichiometric ratio is 1:3:2. Okay, so this is for nitrogen. Okay, and this is for hydrogen and this is for ammonia. Correct? Now what is given to you? Given is hydrogen. Given is hydrogen, and what is the quantity? What is the quantity they have mentioned? Let's see. The quantity of hydrogen mentioned here is 10 gram. Okay, so they have mentioned here 10 gram of hydrogen, so it is a mass that is given. Okay, sir, with stoichiometry, how you can relate, sir? With stoichiometry, how you can relate? We know that 3 mole of hydrogen, 3 mole of hydrogen can give you how many mole of ammonia? 2 mole of ammonia. Correct? Now look here. The ammonia we want it in terms of volume, and hydrogen we need in terms of what actually? We need in terms of mass. So how you can convert 3 mole to respective mass? We know that 3 mole can be written as 3 into 1 mole, and 1 mole will always have a weight that is equal to the mass number, that is mass number expressed in grams. So I can write 3 into 2 gram hydrogen. Okay, so 1 mole have 2 gram weight, so 3 moles are there, means 3 into 2, 6 gram weight, and this we need to express it in the terms of volume. So we know that 1 mole of ammonia, any gas at STP, it occupies 22.4 liter. So here 2 mole is there, so 1 mole will occupy 22.4, so 2 mole will be occupying 2 into 22.4 liter ammonia at STP. Okay, I hope until now it is clear for you. Any doubt? Those who would like to do it, please do it along with me, and if you have doubt, please comment it. Okay, always please understand, we need to do it, then we will learn very fast. Okay, the hand-eye coordination will increase, that's why. So 6 gram hydrogen, so I can write 6 gram hydrogen, okay, will give you 6 gram hydrogen will give you how much, sir? I can write 44.8 liter ammonia at STP. Now how much of hydrogen you have? Because that is the first round we have write based on stoichiometry. That is what I told in the step. We need to write according to stoichiometry. Now we have only 10 grams. So how to convert this 6 gram to 10 grams, sir? I always told you one method. If you want to convert a number to a particular number, what we do here is convert this number to 1 first. For converting this to 1, divide by 6 on both sides. Divide by 6 on both sides. Okay, divide by 6 on both sides. So this will become 1 gram hydrogen. 1 gram hydrogen can give rise to 44.8 by 6 liter ammonia. This much amount of ammonia they can give at STP. Okay. Now tell me, sir, how much gram of hydrogen do you have? Tell me. We have 10 gram hydrogen. So what you need to do? Multiply by 10 on both sides. Very simple. So divide by the same number, then multiply by the number you need on both sides. So this will become 10 gram hydrogen, and this can give you 44.8 into 10 by 6 liter ammonia. So you can do the calculation. So this will become what, sir? This will become 448 by 6. So if you cancel it, how it will become? 6. This becomes 7s are 42. Okay, 2 is there. So 28. So 6 into 4, 24. Again 4 zeros. So 6 into 6 approximately. So I can say 74.6 liter of ammonia approximately. How much it is? 74.6 liter ammonia. 74.6 liter ammonia. I hope any doubt for you. I will one more time I will explain. Okay. So what we have done here, very simple, very simple. So first we try to write the equation relating the question. So nitrogen with the hydrogen gives you 2 mole of ammonia. Then what we need to do, write down the stoichiometric ratio. Stoichiometric ratio is very important. So 1:3:2. Next thing is identify what is given in the question. Given for you to prepare this is hydrogen, that is 10 gram is given. We know that here 3 mole hydrogen. As per the stoichiometry, we need to relate between hydrogen and ammonia. So 3 mole hydrogen can give you 2 mole of ammonia. Now convert this into the respective relevant quantities. Here hydrogen is in mass. So 3 mole, we know that 1 mole will have a mass equal to mass number of hydrogen expressed in grams. So 1 mole will have 2 gram. So 3 mole means 3 into 2, 6 gram it will have. Okay, and any gas at STP occupies 22.4 liter. So 1 mole of any gas at STP occupies 22.4 liter. We have 2 moles, so that's why 2 into 22.4 liter coming here. Okay, now we know 6 gram hydrogen will give 44.8 liter, but we have in our hand 10 gram to prepare. So convert this 6 to 10 gram. How to convert 6 to 10 gram? First divide by the same number so that it will get converted to 1. Then multiply the number we need. Here it is 10 gram, so multiplying by 10. So on doing this on both sides, LHS and RHS, we get the value that is corresponding to 10 gram, how much of ammonia we are getting. That is 74.6 liter of ammonia. Okay, I hope it is clear. So here the detailed answer is given, same methodology. Okay, now we have another important question in front of you. This is directly from NCERT. You know that these days from NCERT the questions are directly asked, correct? So all of you, my sincere request, go through the NCERT, read line by line, and if you are getting some doubts, feel free to comment in our video boxes. Okay, so regarding videos, it's very simple. You go to Brainiacs Classes, type in YouTube Brainiacs Classes, you will get the channel. Just subscribe it and go to the playlist. There you have almost every chapter's detailed videos. That means it's not like some important topics, not like that. The entire chapter thoroughly based on NCERT, you will get it. So once you do that, that would be a very good practice for you. And along with that, we have question bank series there, and we have the revision series right now ongoing. So all these will make you equipped to crack the NEET 2024. In addition to that, if you still feel, sir, we need a classroom environment, you can easily contact us. You can just call the number that is shown below. Okay, you can call Brainiacs Classes, where we have one of the best faculties that is available in Kerala, is coming in Tamil Nadu and taking the class purely in English. And if you have any doubt, you can freely ask them. They are there to help you like anything. So they are like handpicked guys. They are handpicked. They are best in that particular topic, and we are having very fantastic result last years. And we are not investing much on infrastructure like advertisements. So we are only known little. So you can search in Google or you can go to our website to see much of the details. Okay. So let's continue with the next question, that is from NCERT, very important question. This is regarding, again it is same with respect to question is related to stoichiometry only. So the question here is, read through the question. Calculate the amount of carbon dioxide that could be produced when different conditions are given. We will take one by one each cases. So the first case, okay, so the first case is 1 mole of carbon burned in air. So we know that carbon black, that is carbon, when burned in air means oxygen is there. Okay, we know that carbon will get oxidized. And what you will get, sir, when carbon is oxidized? We know the very famous compound, that is carbon dioxide. Okay, which is a gas, and oxygen, which is a gas. Okay. So this is the equation they are talking about. We can put it in a circle for making it little more focused. Okay. Now what they are giving? They are asking if 1 mole of carbon is burned, what will happen? Or how 1 mole of carbon is burned in air, how much amount of carbon dioxide is produced? Okay, since the amount is asked, we can say they might be expecting this thing in different things. If they should mention whether it is mass, volume, or things, so we will take it everything, since amount can be anything actually. Okay, so in the options they may be mentioned. Based on that you can choose the answer. So first thing, what you need to write, sir? Very simple, stoichiometric ratio. So what is the stoichiometric ratio here? 1:1:1. That is the stoichiometric ratio. So what does that mean? It means very simple, 1 mole of carbon, 1 mole of carbon atom, 1 mole of carbon atom can give rise to 1 mole of carbon dioxide. Okay, answer is completed in one shot. But we can say they may not give this 1 mole of carbon dioxide as such. They may be telling this in mass in grams. We know that 1 mole of carbon dioxide means mass of carbon dioxide is mass number of carbon dioxide expressed in grams. So I can say 44 grams CO2. So 1 mole carbon dioxide is equivalent to 44 grams CO2. Or it can be volume. In that case, 1 mole is occupying 22.4 liter at STP. So we can say 22.4 liter carbon dioxide at STP. Okay, and we know that, and this is still equal to what? 1 mole is still equal to 1 gram molecule. Sometimes they may say in that 1 gram molecule CO2. Okay, and this 1 mole is also equal to number of molecules also they can use. In that case we can say Avogadro number CO2 molecules. So that's why I told this can be expressed in different way. Okay, and even this can be written in terms of atoms also, because 1 mole carbon dioxide, if you say it has 1 mole carbon atom plus how many mole of oxygen atom? We can say atomicity is 2, so 2 into 1 mole oxygen atom, that is 2 mole of oxygen atoms. So this is the different way you can express it. Okay, so I hope this is clear. So can we go to the next part of the question? That is 1 mole of carbon is burned in, there they are mentioning 16 gram of dioxygen. So in this question you can see one thing, there is no limiting reagent, because here only one stuff is given. That means given quantity is given only for carbon. Okay, so I told minimum given quantity is given for 2 stuffs, then only you can consider limiting reagent. Otherwise you don't need to even consider limiting reagent. So in the next part of the question, if you see, you can see they have mentioned 1 mole of carbon and 16 gram of dioxin. That means 2 quantities are coming into picture. So there we have a comparison. So we need to check whether limiting reagent is present or not. Okay, I hope you are getting the concept. Okay, so let's start doing the second part of the question. Okay, so second part of the question also talk about the same reaction, that is carbon with oxygen gives you carbon dioxide. Okay, the same thing. And what is the stoichiometric ratio? Stoichiometric ratio again same, 1:1:1. This is the stoichiometric ratio. Now the given is changed. Given has changed. So what is given? Let's say, so they have given 1 mole of carbon atom, 1 mole carbon atom, and they have given 16 gram of oxygen also, 16 gram out. These are the 2 things given. So first we need to check whether any limiting reagent is present or not. For that, what we do is we convert mass also to moles. So here we don't need any change. So this should remain as 1 mole carbon atom. And here 16 gram of oxygen is how much moles are? We know that 16 gram is the mass number of O2. So this corresponds to 1 mole. We know that 1 mole of O2 means its mass number expressed in grams. So I can say, but here one problem is there. O2, the mass number is 32. So here I have made a mistake. It is not 16. That is for oxygen atom. So this is 32 gram. 32 gram it should be. Okay. Because O2 means 16 into 2. 2 oxygen atoms are there. So it's 32 gram. Now tell me 16 gram will be how much mole? So divide by 2 to make it 16. So dividing by 2 on both sides, this will become 0.5 mole O2. Okay, now we got the number of moles of O2, that is 0.5 mole O2. So students, please remember, for hydrogen or oxygen, they are existing as molecule as H2 or O2. So always when we are considering the mass number, don't forget H2 means 2 will come, O2 means 16 into 2, 32 will come. Usually I also will make this mistake, so just now you have seen it. Okay, so don't do this in exam. Okay, so once you have converted this to number of moles, next what we need to do in order to check whether there is a limiting reagent or not. Next, divide the number of mole, divide that number by stoichiometric ratio. So here the stoichiometric ratio of carbon atom is what actually, sir? It is 1. So I will divide by 1. Okay, and here the number of moles is 0.5. Divide that also by the respective stoichiometric ratio. Okay, for O2 you can see again the stoichiometric ratio is what? 1 only. So I will divide by 1. Okay, once you have divided, check which is a lesser number. So I can see this is the lesser number here. Okay, this is the lesser number after division. So I can put it like this. This is greater. So which one is the lesser number? That guy is the limiting reagent. So this is the limiting reagent here. Okay, and we know that this corresponds to whom? This corresponds to oxygen. So I can say in this reaction O2 oxygen is the LR. LR means limiting reagent. So tell me, sir, how to find limiting reagent? One more time, just I am explaining. So write down the given quantity. If mass is there, convert that to respective mole. Here already it is in mole. Then divide by the respective stoichiometric coefficient. Here both are 1. After that, check which one is the lesser number. So here this is the lesser number. So I can say this is corresponding to oxygen. Then I can say oxygen is the limiting reagent. Any doubt? Simple. Correct. Okay. So oxygen is the limiting reagent. Now what is the importance of limiting reagent? That's very important. Please understand, if there is a limiting reagent in any of the reaction, that limiting reagent will decide how much amount of product needs to come. Okay, that limiting reagent will decide how much amount of product needs to come actually. Okay, this is very, very important. 1 minute, there is some interruption. Don't worry, we'll open it up one more time. Okay, so okay, we'll go to downloads, then we will try to open it up. Open with GoodNotes. Okay, yeah, you can cancel it. Yeah, now I think the issue is fixed, I think somehow. Yeah, don't worry. Okay, so what I was talking about was with respect to limiting reagent. Okay, so limiting reagent, if there is present in that compound, then the limiting reagent will decide how much quantity of product needs to be formed, and limiting reagent will decide how much quantity of other reactant needs to be consumed in the reaction. So we now will speak everything with respect to limiting reagent. Okay, so how we can write that then? So we say limit with respect to limiting reagent, we say, okay, so 1 mole of oxygen. Now with respect to stoichiometry, we know that 1 mole of oxygen, listen, 1 mole of oxygen can give rise to 1 mole of carbon dioxide. So we will write with respect to oxygen based on stoichiometry. Okay, that is the next step. So we write 1 mole O2 can give rise to 1 mole carbon dioxide. Now what we need to do? We know that oxygen, how much quantity do we have in our hand? In our hand we have 0.5 mole of O2. So how you can convert this to 0.5? So we can easily say, okay, we can easily say divide by 5 on both sides. Not divide by 5. If you want to convert this to 0.5, divide by 2. Sorry, divide by 2 on both sides. So this will become half mole O2, half mole O2, and this will become what? Half mole CO2. Okay, now we know exactly half mole, 0.5 mole of oxygen can give half mole of CO2. But the problem here is what they have asked in the question. So again, they have asked the question in generic way, amount of carbon dioxide. So we can convert this into different quantities. Half mole of CO2 means corresponds to how much? We know that 1 mole will have a mass weight equivalent to mass number expressed in grams. So half mole will have how much weight? I can say take half of it. Okay, divide by 2. So this will become 22 gram CO2. And this is equivalent to how much? Avogadro number of molecules divide by 2. Na by 2 CO2 molecules. Okay, and this is equal to what? 0.5 gram molecule CO2. Correct? So like that, this can be expressed in different ways. Even in volume, we can say that would be 22.4 divided by 2. It will become 11.2 liter CO2. Like that, you can express in different ways. So I hope it is clear for you, the question. Very simple. Once you find the limiting reagent, with first we need to do what? Write down the reaction between whom we need to relate oxygen and carbon dioxide. So first write in terms of stoichiometry. 1 mole O2 can give 1 mole CO2. Then convert this 1 to the given quantity. The given how much amount of oxygen is given? 0.5. So convert this to that. Then this will give you the respective amount of carbon dioxide. Okay. So I hope you could see that. Okay. Here also I have mentioned it. So you would get the same answer here. You can see here. Okay. Now let's try to see the last part of the question. We will read it. Okay, the last part of the question. So we'll go there. Last part. So last part is 2 moles of carbon are burned in 16 grams of oxygen. So only thing is they have increased the 1 mole to 2 mole. So what change they will become, sir? Very simple change. Correct? All of you listen. Come on. So stoichiometric ratio again 1:1:1. So I changed the given value to 2 moles of carbon, and here again 16 gram of oxygen. So 16 gram of oxygen means again we know it is corresponding to, we know 32 gram corresponds to 1 mole O2. So 16 gram will be 0.5 mole. Correct? So 0.5 mole O2 is present. Next we need to check limiting reagent is present or not. So limiting reagent, how you check? Divide this number by stoichiometric ratio. Here divide by stoichiometric ratio. Again we can see that this number is very less. So this corresponds to oxygen. Okay, this corresponds to oxygen. So I can say 0.5 lesser number. So there is a limiting reagent. So again we need to write oxygen is the limiting reagent. O2 is the limiting reagent. Now we will write based on stoichiometry. Again the same thing will come based on stoichiometry with whom we need to relate O2 and CO2. So 1 mole O2 can give 1 mole of CO2. Now what is the amount of oxygen you have? 0.5 mole. So I can say 0.5 mole carbon dioxide is related. Again the same answer, 22 gram carbon dioxide is produced. Na by 2 molecules of carbon dioxide, 0.5 gram molecules of CO2, 11.2 liter CO2. Okay, but here you can see one important inference. That's what I want to focus. Here you know that in this reaction oxygen is the limiting reagent. Here also O2 is the limiting reagent. So even though the number of moles of carbon are increased, okay, there is no difference in the amount of carbon dioxide produced. Why? Because we know that oxygen is the limiting reagent, and this guy will only decide the number of product formed. The other reactant, if you increase it as much also, it will not affect the amount of product formed. So please understand, the most important inference here is If there is a limiting reagent present in a particular reaction, then that limiting reagent will decide how much quantity of the product needs to be formed and how much quantity of other reactant needs to be consumed. Okay, I hope it is clear for you. Okay, so students, how are your schools ongoing? This for long-term students. So I know that for you, most of the half of the chapters might be completed. Okay, if you have any doubt in any of the chapters, feel free to contact us. We are also giving chapter-wise support also. So any doubt, you can directly go to YouTube videos and watch it. You can go to Brainiacs channel, go to playlist and find your respective chapter. There you can see it. And those who say that, sir, I need some classroom environment, we are also offering that. So you can come to Brainiacs classes. There we have a very good number of students who is undergoing very good coaching for NEET and JEE. But we focus mainly on NEET. Okay, JEE we support mainly physics and chemistry. Okay, we say it openly, it's very clear. And if you have the passion to become a doctor, I will surely recommend Brainiacs classes, because you have as many number of tests. Daily test is there, doubt clearance portals are there, and in addition to that, very good printed notes along with other materials, everything is given. And all these things comes at a very affordable fee, somewhere around 60,000 rupees. Okay, I think no institute in Coimbatore or Tamil Nadu is giving at a very low cost. All of them are giving above 1 lakh. Okay, so at this point of time, we are actually supporting our students at a very low cost. This cost also, as you know, like most of the 90% of it is given for faculties, to bring the best faculties from Kerala. Okay, so if you have a passion to become a doctor and you want to find a right place, I may say Brainiacs classes is one of the best in that area. Okay, yeah, let's go to the next question. So we have a next question in front of you. All of you can go through it. Okay, this is also a very important question. The same reaction. Okay, yeah, I hope you could see it. Yeah, so the question is, at NTP in a container, 100 ml nitrogen and 100 ml, you can see here 100 ml nitrogen and 100 ml hydrogen are mixed together. Then find out the volume of ammonia. So from this question itself, I can predict two things. So the given quantity is given for nitrogen, also the given is given for hydrogen. So since both are present, we need to check which among the following is the limiting reagent in this one. That is for sure. And both of these are given in volume. Okay, so if it is mass only, you need to convert that to number of moles and check it. But if both of them are in volume, you don't need to convert this into number of moles to find the limiting reagent. It is not required. Only when mass is given, you need to do that. Okay, so let's see the answer. So this is the reaction. N2 plus 3H2 gives 2NH3. We have discussed the reaction just now. And what is the stoichiometric ratio? 1, and here it is 3, and here it is 2. Okay, and given is what? 100 ml nitrogen, 100 ml nitrogen and 100 ml hydrogen is given. Now first we need to check whether limiting reagent is present or not. So what we need to do, sir, in order to check that? So we know that take the volume value, divide by the respective stoichiometric coefficient. So 100 by 1. Here also take the given value 100, divide by the respective stoichiometric coefficient 100 by 3. So while dividing itself, we could understand that 100 by 3 is the smallest number. So if that is the smaller number, then the respective one, that is hydrogen, which is the limiting reagent. So here I can say hydrogen is the limiting reagent. Now we will speak everything with respect to hydrogen. So as per stoichiometry, tell me, sir, how hydrogen is related to ammonia? We know that 3 mole of hydrogen can give you 2 mole of ammonia. So first we will write with respect to stoichiometry. Okay, so 3 mole, and we can even write directly as 3 ml of hydrogen. Why? 3 mole of hydrogen is equivalent to 3 into 22 or 22400 ml hydrogen can give rise to what? 2 mole. So 2 into 22400 ml ammonia. So if you cancel it both sides, 22400 ml, then it will become 3 ml hydrogen gives 2 ml ammonia. That's how. One more time I will write. So 3 mole means 3 into 22400 ml hydrogen, giving rise to 2 mole means 2 into 22400 ml ammonia. What you need to do? Cancel it on both sides, same number. So what it will means 3 ml hydrogen can give rise to 2 ml ammonia. So that is what I have written here. 3 ml hydrogen can give rise to 2 ml ammonia. And it needs how much ml of nitrogen? We know that 1 mole, that is again equivalent to 1 ml nitrogen. Actually, we don't need to consider this because they are talking with respect to amount of ammonia that is formed in the question. So if you read the question, they are asking find out the produced volume of ammonia. So that is for learning purpose only I have written that. Okay. So 3 ml can give 2 ml of ammonia. How much ml do you have in your hand? In our hand we have 100 ml. So how we can convert 3 ml to 100 ml? First divide by 3 on both sides, here and here. This will become 1 ml and this will become 2 by 3 ml. Then multiply by 100. So this will become 100 and this will become 2 by 3 into 100. Okay. So that's why you can see here 100 ml hydrogen gives 200 by 3 ml of ammonia. So I got the answer, that is 200 by 3 ml ammonia. Okay. So my answer is this one. So for that, how much ml of nitrogen is consumed? 100 by 3 ml of nitrogen is consumed. Okay. So very simple. So again I am telling how to convert 3 ml to 100 ml. 3 ml can give rise to 2 ml. This is what we know, 2 ml ammonia, 3 ml hydrogen. So first divide by 3 on both sides. This will become 1 ml hydrogen giving rise to 2 by 3 ml ammonia. Okay. Then multiply by 100 on both sides. So this will become 100 ml hydrogen giving rise to 200 by 3 ml ammonia. Same thing. So I put it in a single step. I got the answer very immediately. Hope you understood the question. Any doubt? Very simple, right? So just follow this. You can get all the questions from this chapter. So just to read this material, this is sufficient. Almost all types of questions are handled, especially based on NCERT. We have other types of question in the gates and everything, but you know, right, these days questions are directly from NCERT. So I have tried to take up almost all important questions from the NCERT and have made the discussion. So if you have any doubt, feel free to ask me, okay, in the comment box. So we are here to help you, or even you can contact Brainiacs Classes directly. The number is just scrolling down. You can just note down that number and call it. Okay, and please don't forget to subscribe the channel. It's very, very important. You will get all the latest Neet news, and also you will get all the updates and all chapter revisions, everything you will get it, sir. Every day the classes are going live on the channel. So just subscribe it and enjoy. Take down the notes and learn it, and wish you all of you would become great doctors. Okay, yeah, we'll go to next question. So the question here is, for the reaction 2A plus 2B gives, it's a hypothetical reaction, A plus 2B giving C, the amount of product here is C, formed by starting 5 mole of A. I'm starting with, given is 5 mole of A and 8 mole of B. Since both, we can see both two reactants are given and both of them have given quantity, then I can say there is a case of limiting reagent comes into picture. We need to check which among the following, that is A or B, is the limiting reagent. We will see that. Okay. See here, first step is what, sir? Tell me. First step is writing down that reaction. A plus 2B gives what? C. Next thing is writing down the stoichiometric ratio, that is 1 is to 2 is to 1. That is the stoichiometric ratio. Now next step is what, sir? Writing down the given actually. What is given for you? Given is 5 mole of A and 8 mole of B. Now what we need to do? We know that what is the next step? Divide the given number, given quantity by the respective stoichiometric value. So this would become 5 divided by 1 and this would become 8 divided by the respective stoichiometric number, that is 2. And check out which is the smaller number. So we can see 2 by 8 is 4 and hence it is a smaller number. So this corresponds to whom? B. So I can say that in this question, who is the limiting reagent? I can say very easily B is the limiting reagent here. Okay, now we write, we talk, we say everything with respect to B. First, with respect to stoichiometry, we will see. Okay, we can say that 2 mole of B can give rise to 1 mole of C. So that's what first we write. 2 mole of B can give rise to 1 mole of C. This is not, we don't need to write, but for information we are writing. So as per stoichiometry. Now we need to check how much mole of B actually there in your hand. How many are there? We know that B, how much moles are present with you? 8 mole of B is given to you. So just next we need to check how you can convert this 2 mole to 8 mole. So we know that we need to multiply by 4. So if you do that multiplication here also, you need to multiply by 4 on both sides. So this will become into 4, this will become into 4, then this will be 4 mole of C. So I got the answer, 8 mole of B can give rise to 4 mole of C. So my answer would be 4 mole of C. Clear? Very simple. So first you write with respect to stoichiometry, then convert that value to given quantity. Don't forget that many students will make a mistake, like they will convert this to 4. Don't take it. Given value is given, with that given amount of B, how much amount of C can be produced? That is the question. So convert that to 8 and see respectively how much amount of C is formed. Okay, so it's very simple. I hope you understood. So next is also an NCERT question, very important question. Okay, similar one. All of you read through the question and check if you have any doubt. Okay, and what else? Students, and one more thing, this time we know it's a Medical Council of India is conducting the exams. So here also we hope today from NCERT the questions are used to come, and some syllabus is cut. If you see in the new NCERT textbook, some topics are not there. So my sincere request, initially focus on the topics that is present in the new NCERT, and thereafter once the notification comes in November, then we will maybe we can increase our learning. That would be better, because right now focus on what that is present in NCERT, because +2 students are also writing the exams and they are learning the new NCERT. So in my understanding, 90% they will have the new syllabus for NEET exam that includes the reduced topic. So please don't waste the time with the old NCERT. Okay, this is my sincere request. If you think logically, that would be the best decision you can follow up to November. Okay, now you have the question. You can read through the question. 1.5 mole of oxygen combines with the magnesium to form magnesium oxide. The mass of magnesium that has combined, that's what they are asking. So here you can see that only one of the reactants quantity, given quantity is given. So here there is no concept of limiting reagent will come into picture, correct? So let's try to write the equation and try to solve it. Okay, so the equation here is magnesium react with the oxygen to form magnesium oxide. So every time when you write the equation from your side, please check whether it is balanced. All these concepts are based on balanced chemical equation. Balanced chemical equation. So equation should be balanced. That is very, very important. Okay, here you can see it's a balanced equation. 2 magnesium atom present here, here also 2 oxygen atom, here also 2 oxygen atoms are present. Next we know we need to write down the stoichiometric ratio, that is 2:1:2. That is the stoichiometric ratio. Here you can see 2 and here it is 1 and here it is 2. Okay, next with whom we need to relate, that is very important. We need to relate between, we need to calculate the mass of magnesium and what is given, oxygen. So we don't need to consider the product here. We need to consider magnesium with the oxygen. Okay, so that is what we need to find out. So I have mentioned it very clearly, since the given value is only for oxygen, there is no need to apply the concept of limiting reagent. Very, very, very important. So we need to relate between magnesium and oxygen. So from stoichiometry, please write it down. 2 mole of magnesium can give you 1 mole oxygen, or we can write 2 mole magnesium needs 1 mole oxygen. Now next thing is how much amount of magnesium how much amount of oxygen you have in your hand. In my hand I have, if you see in the question, they have given 1.5 mole oxygen is present. Okay, so what you need to do, sir? Next you need to convert the value 1 mole of O2 to 1.5 mole. 1 we need to convert to the given quantity 1.5. So to converting 1 to 1.5, you can multiply 1.5 on both sides. So this will become 1.5. This will become 2 into 1.5. That is nothing but 2 into 3 by 2. That is what written here. Okay, so 2 cancels out, so you will get the answer as 3 mole of oxygen. That means 1.5 mole of oxygen, 1.5 mole of O2. Okay, you need to write it as O2, very simple. So 1.5 mole of O2 needs what, sir? How much amount of magnesium is required? 3 mole of magnesium is required. But if you look at the options, they have given magnesium in terms of mass, they have given, correct? So how can you convert that to mass? Very simple. 3 mole magnesium. We know that 1 mole of magnesium will have a weight equivalent to mass number, that is 24 gram. This is the mass of magnesium, mass number of magnesium. So 3 mole will have what weight? Multiply by 3 on both sides. So this will become 24 into 3, that is 72 gram magnesium. You got the answer like that. Clear? So it's a very simple question. I hope you understood. So similar to this, you can do any questions that is present in the NCERT. Okay, just to focus on the concept and do it. So we have a very good question that came for JEE. Okay, even though it came for JEE, but it is of NEET standard. This is one question I am expecting for this year NEET exam. So all of you don't skip this question. Please note it down in your notebook and do it while you are revising. Okay, very important question. So let me write here, very important. Okay. So first we will read the question and then try to find out the answer. Okay. All of you listen. Okay. Yeah, regarding Brainiacs classes, what I can say, other stories. So we started this Brainiacs classes, let me say 5 years before. So like it was like the time when NEET was introduced in Tamil Nadu. So at that point of time, we were working in other institutes where we were teaching like main subjects. And we understand that mainly the problem when we do in other institutes as a teacher is there they have a time frame. With that, they need to complete the topics because if the time increases, you need to pay more amount to faculties. So that is a problem for the business actually. So we were not satisfied, like we were not able to give the complete teachings or complete topics for our students. We need to complete that chapter maybe in 3 hours, 4 hours. It was very difficult for us actually because the students are not getting good quality education. So at that point of time, we thought, okay, let us start an institute from our side where we focus on quality education. Okay, so to be frank, actually, if you want to do any chapter sincerely with all questions and everything, we need minimum 12 to 13 hours or 15 hours is mandatory. And if you say basic concept of organic chemistry and all, you need minimum 40 hours to complete that chapter. Ray optics, all those are very big chapters. So in Brainiacs classes, we give sufficient number of hours. We do all sort of practices, everything, because we want the student, because they are learning for the first time, sir. They are preparing it for the first time. So they need the time to come to that particular pace. So we are actually focused on that, and we know this actually. So we are actually taking out all average students mainly, because in our case, we are not doing much of the promotion or nothing. So average students usually come to us with maybe say 100 marks or 150 marks, and they say, sir, we need NEET, sir, we are interested, I have a passion to become doctor. So we encourage those students to become doctors by scoring more than 600. So it's like 100 coming to 600 just to check the amount of percentage of marks that is getting increased. But if you go to some premium institutes, you can say all toppers are there, almost like 550, 580 are there. They are scoring 670 or 680, 100 marks increase. We have all our results are from average students who sit with us, who spend their time with us. They were obeying like anything, and we were mingling like anything to get the best out of them. So I am saluting Brainiacs classes in that aspect, to give the best to the society. Okay, so let's start to do this question. It's a very important question. Okay, so we have the question like 10 ml of a gaseous hydrocarbon. We don't know what is this hydrocarbon. That makes this question little bit interesting. Okay, 10 ml of gaseous hydrocarbon on combustion gives 40 ml of carbon dioxide and 50 ml of water. Then they are asking you to identify what is this hydrocarbon, which is this hydrocarbon. How to do this? We know that hydrocarbon, when it is oxidized, we have a general equation. We have learned this in our part 1 series. So those who have not visited our or watched our part 1 revision series, please watch it. That is very important. You can go to Brainiacs Classes playlist. There you can see BRIV, Brainiacs, BIRV, Brainiacs Intermediate Revision Series. There is a playlist is there. You can click there. You can get the video. Okay. So you can see that is we will go to our general equation. So this I have explained in this equation I have explained in the first series. So this is my general equation for any hydrocarbon which undergoes oxidation. Please learn this, very important. Don't skip this. So if a hydrocarbon has CXHY, which is the coefficient number CXHY, and if this is oxidized, this will be the respective stoichiometric coefficient for this oxygen, X plus Y by 4. And that will give you how much amount of carbon dioxide? X mole of carbon dioxide and Y by 2 mole of hydrogen. You need to learn this, then only you can solve this question. Okay, so from this I can write clearly that 1 ml, if I am taking 1 ml CXHY, this can give you X ml of carbon dioxide, correct? This is based on stoichiometry, correct? Why I am writing that? Because 1 mole CXHY gives 1 mole, X mole CO2. So if I convert this mole to volume, what I can say? 22400. Then 22400 will cancel from both sides. Then I can say 1 ml CXHY can give X ml CO2. Correct? Or you can think like this. If everything is a gas, you can directly write in volume. No issues. Because 22.4 or 22400 is going to cancel from both sides. Okay. So 1 ml CXHY. 1 means this one give rise to X ml carbon dioxide. Okay, now what is given to you? How much amount of CXHY is given to you? 10 ml. This is mentioned in the question. If you read the question, you might have noticed it. They have given 10 ml gaseous hydrocarbon gives 40 ml CO2 and 50 ml water. That is mentioned. Okay, so I can write here from this one 10 ml CXHY is giving you. So if you want to convert 1 to 10 ml, this is a given quantity, so you need to multiply by 10 on both sides. So this will give you 10 ml CXHY and 10x ml carbon dioxide. And we know that how much amount of carbon dioxide is obtained. It is already mentioned in the question. As per the question, they are telling 10 ml hydrocarbon gives 40 ml carbon dioxide. So 10 ml gives 40 ml. So that means this number, this 10x is equivalent to 40. Correct? 10x is nothing but 40. So we can write 10x ml carbon dioxide is equal to 40 ml carbon dioxide. So we cancel this one ml. Then we can say x is equal to 4. From that we got x value. And similarly, we can write for hydrogen also. 1 ml CXHY can give you Y by 2 ml hydrogen. From where the Y by 2 is coming? Because it is a coefficient as per the stoichiometry. Okay. So 1 ml CXHY can give you Y by 2 ml. And given you how much amount of CXHY? 10. So convert this 1 to 10, multiply by 10 on both sides. So this will become 5Y ml of H2. And in the question it is mentioned very clearly 10 ml hydrocarbon gives 50 ml water, it is mentioned. So this 5y ml water is nothing but 50 ml water. So cancel ml on both sides and y becomes 10. So we got x and y for you. So x and y you are getting. So x is equal to 4 and y is equal to 10. So we can substitute in our hydrocarbon, that is CXHY 4 and 10. So my hydrocarbon is C4H10. Very simple. Okay, so the given, based on the given you can substitute and get the answer. So it is given in the options C4H10 it is mentioned. I hope. Yeah, this is a very important question. Option 4 is the correct answer. Okay, so it's already mentioned 40 ml of CO2 is obtained and 50 ml of water is obtained when 10 ml of gaseous hydrocarbon is there. So you just need to know this equation to find out what is X and Y. Clear? So this equation, please remember, very important. Okay, then you can easily fix this question. I hope it is clear for you. Okay, next is also a very important question that also came for NEET exam, not for NEET, JEE, but it's very important for NEET this year. Okay, so I hope all of you are listening to it. Please note down this question in your notebook, very important. Okay, so just read through the question, we will read it. Okay students, how do you are feeling this year repeat for NEET exam? I know that this is a mid period. Most of the students will feel lethargy or energy less, because we know that whenever you join a course initially, you will have plenty of energy, and at the end when exam is coming, then also you will have all that energy will come into picture. But in between that period of time, you may feel lethargic, you may feel like relaxing a little. Please understand, you are spending 1 year for NEET repeat, so don't do that rest. Always focus, always visualize you becoming doctor. Before you go for sleep, visualize like you become doctor, you are in medical college, visualize it and sleep. So next, each day you come close, little close to that, cracking that. So for that, what you need to do, that single step, that small step is required. Okay, so please focus only on what you need actually. Remove all other distractions from you, like Facebook, Twitter, whatever it is. So I am sincerely requesting you to focus only on YouTube. Why I am saying YouTube is, don't go and watch videos other than entertainment videos. Focus on the learning channels and try to learn as much as you can. Okay, try to get different tips from different sir and try to note down in your notebook and revise it. Revision is a very important part in cracking NEET. It is not the IQ, sir. I have told many of my students, sir, IQ has very less role. It is all about revision, how much you are understanding. Some student may be understanding a topic maybe in let me say 2 minutes. Other student maybe, let me say, in 1 day or 2 days. That doesn't matter. Once you have learned the topic is not going to change. Practice it. Those who are going to practice it as many times or revise it as many times, they are going to come at the top. That is for sure. No doubt in that. In my 16 years of career, I can clearly say those students who have understood the topic and did as many revisions by writing, they have come to the top. Okay, so please follow that. That is the only way you can crack the NEET exam. Okay, now let us do this question. Okay, the question is, assuming that petrol is octane. Octane is what? C8H18. Has a density that is mentioned 0.8 gram per ml. They are asking 1.4 liter approximately of petrol on complete combustion will consume. If this much amount of petrol is burned, that means how much amount of oxygen will be consumed. We know that for combustion oxygen is required, so how much amount of oxygen they will be consumed. Here also you can see only given quantity is given for petrol only, that is only for octane. Then we can say there is no limiting reagent will come into picture. Let's try to see how to solve this question. So why this density is given, we will try to see why that density is required. Okay, yep, yeah, you can see here petrol or octane has a density of 0.8 gram per ml, and volume of the petrol is mentioned. And we know that if density is known and volume is known, we can calculate the mass. Then many students will ask, sir, why can't we do it with respect to volume, octane? Because we know that octane has a mass number C8 or H18, which is huge mass. It is not a gas. We know that petrol is a liquid, sir. So we cannot apply the concept of STP and everything. It is not possible. That is the reason why density is given in the question. Very important. Similar to water. Whenever water is given and they say it is not water vapor, always if you want to calculate mass, means we need to apply density is equal to mass by volume. We have seen similar questions initially in our part 1 series. Very important. Don't forget this. So we will first calculate the mass. So mass is what here from this equation? Mass is density into volume. So density is 0.8 gram per ml into volume, that is 1.425 liter. So if you multiply this with 1000, this will become ml. So 1425. So you can say 0.8 gram per ml into 1425. So if you multiply it, you will get the mass of the petrol that is used in this reaction. So the mass of the petrol is coming around 1140 gram. So this is the mass of the petrol that is being used. Now we need to identify how much amount of oxygen is required for burning this much amount of petrol. So we need to write that equation. Again, that equation comes into picture. So here x is equal to 8 and y is equal to 18. Similar stuff, CXHY, and here we know x plus y by 4. X plus y by 4. X we know 8. Okay, y we know 18. So 18 by 4. So cancel it. 2 into 9, 2. So 9 by 2 will come into picture. So 8 into 2, 16 plus 9, 25 by 2. That is how 25 is coming into picture. And this we know x amount of CO2. That's why 8 CO2 is coming into picture. And this is y by 2. Y by 2 here 18 by 2. That is how 9 is coming into picture. Understood? So that's the reason why I told this equation is very important. CXHY gives x plus y by 4 O2, and that is giving you x CO2 plus y by 2 H2O. For any hydrocarbon which undergoes combustion, we need to know this particular equation. Okay. So based on that, the balancing the equation becomes very easy. Why? Because always the products are carbon dioxide and water, but the coefficient is very difficult to get. That is the reason why we are learning or by hearting that equation. Okay. Now let's learn. So we know petrol. This petrol needs to be related with oxygen. So from the stoichiometry, we can say 1 mole octane gives 25 2 mole. We can say 25 by 2 mole oxygen is needed. But how many moles you have, sir? Or we can say 1 mole of octane is how much gram? So to convert that, what is the mass number of C8H18? It is coming around 114. So we can easily say 1 mole of octane is nothing but 114 gram octane. So 114 gram octane needs 12.5 mole O2. 25 by 2 is 12.5. Correct? 12.5. So tell me, sir, how you can convert this 114 to our given quantity, that is 1140, or we calculated that value 1140. So multiply by 10 on both sides. So this will become 125 mole O2. That means 1140 gram of octane needs 125 mole oxygen. It needs 125 mole oxygen. So that is already given in the options. So option 3 is the correct answer. I hope you understood. So here they have mentioned volume. We multiplied with the density to find out the mass that is used. With respect to that mass, we calculated how much amount of oxygen is required. That was 125 mole O2. Clear? I hope the concept is clear for you. So whenever you have a liquid is given, so convert that to mass to find out the respective other quantities. Don't forget, and don't forget the combustion equation of hydrocarbon. Again I am writing CXHY gives x plus y by 4 O2 giving x CO2 plus y by 2 H2O. Very, very important. Okay. So next we have another important question in front of you. So the question mentioned here is, they say insulin, we know insulin is a hormone that is present here. Insulin, pancreas produce insulin. It's required for sugar metabolism. So insulin contains, they are telling 3.54% sulfur. Then they are asking what is the minimum molecular weight of insulin. What is the minimum molecular weight of insulin? For this type of questions, this comes under the topic percentage composition. Until now it is not asked in the NEET exam, so you can even expect that for this year. Okay, so let's see how to handle this type of questions. So we know this fundamental formula, mass percentage of an element, very, very important. Mass percentage of an element is equal to, how you calculate that, atomicity into atomic mass of that particular element into 100 divided by molecular mass of the compound. Here now molecular compound in our question is insulin. Okay, mass percentage of which element is given? Sulfur is given in the question, 3.4. So if you want to find the minimum molecular weight, what is the minimum molecular weight here means? Why they say minimum molecular weight means that particular compound, that is insulin, has only one sulfur atom. We don't know how many sulfur atoms are there. That is the reason why we are calculating minimum molecular weight. Minimum molecular weight means at least that element is present, right? So it should be 1. 1 should be present there. So we take atomicity is equal to 1. That is the reason why atomicity is 1 taken. Why? In the question they have asked minimum molecular weight. When minimum molecular weight is asked, we don't know actually in that insulin how many sulfur atoms are there. If it is minimum, what is the minimum? That molecular weight means minimum 1 sulfur atom should be there. That is the reason why in all minimum molecular weight we assume that particular atom is present as minimum as 1. So atomicity is 1 and atomic mass of sulfur atom is 32 into 100. From that the minimum molecular weight you can calculate. So it will come around 3200 by 3.4. You will get the answer as how much, sir? So 3200 by 3.4, you will get it as 941.17. You can do this very easily. Multiply by maybe one more zero, so 32,000 by 34, it will come into picture. Divide by 2, this will become 16,000 by 17, and maybe we can take 160 by 17 into 100. So let us assume this is 16, then it will become what? 10, then it will become 1000. So this is 17 means little less than that. That's why 941 is less than 1000, 941. Like that easily you can do it. Shortcuts. Okay. Now we go to the next type of questions, or the last type of questions in this chapter. That is how to find the molecular formula when their atomic weights are given. How to find the empirical formula. All these type of questions will come under this category. Very easy type of questions. If I think last year NEET or 1 year before, this type of questions were asked. So this year also it can be asked. Okay, just to practice it, nothing more. So what is it all about? We will read the question. There is a compound that is made up of two elements X and Y, and they are mentioning they have equal mass present in them. So both of them, both X and Y are present in equal quantity. So don't think like it is XY. Don't assume that it is a mass actually. Okay. So it won't be equal. Okay. It can be equal or may not be equal. Don't assume it simply as XY. Okay. So usually in NEET, they will give the option as XY or X2, Y2. You can say here X3, Y3 like that. Don't assume it initially itself. They are given the initial atomic weights are 30 and 20. What is the molecular formula of the compound? In all these types of questions, what we do is we create a chart similar to this. In that element would be there. Its mass, what is mentioned, would be there. Then the atomic weight, it is mandatory, it should be there. Okay, so element is X and Y. The mass, they are tell equal masses. So let us assume both of them are present in 1 unit. You can take it even 2, 3, but here if you are taking 2, here also it should be 2. Here if you are taking 3, this should also be 3. That is the only thing. Okay, so here the atomic weight is mentioned as 30 and 20. Now next we need to find out the number of moles. So to find out the moles, what we do? Mass by atomic weight. This we will do, mass by atomic weight. So 1 by 30 and 1 by 20. So you got the number of moles. Now we need to make that as a simplest ratio. How will you convert this to simplest ratio? Out of this, which one is the smaller number? Smaller number is this one. Divide that by whole. Here also divide by 1 by 30, and here also you divide by 1 by 30. So if you are dividing this, this will become 1. That is the simplest ratio. Then you will get. This will become 30 by 20. That is 3 by 2. So now you know it is X and Y is 3 by 2. So to make it as an integer number, you multiply by 2 on both sides. So this will become X2 and Y3. From that you will get what? The empirical formula. Okay, so the value of mass is taken as 1 for both, since it is given they have equal mass. That's the reason. So just now we have got the empirical formula for this particular question. So Okay, so please correct this question. It is empirical formula you need to calculate. It is not molecular formula. Empirical formula we need to calculate. Okay, so we are correcting it as because first question we are doing, right? So we will convert this to empirical formula. Okay, empirical formula. So empirical formula, I will also teach you how to calculate molecular formula also, don't worry. Okay, this is empirical formula we are calculating. Okay, now we have another question. Here also we will calculate how to find empirical formula. Read through the question, all of you, sir. An oxide of sulfur, so we know that sulfur and oxygen are the two elements, contains 50% sulfur in it. So if sulfur is 50%, surely percentage means 100, so oxygen should also be present in 50%. Okay, so here also they have equal mass. Its empirical formula is, that is the question. So how to do this? Again, the same table you can make it. Element we can do, percentage we can do, atomic weight. So sulfur, oxygen, percentage is 50 and atomic weight. So here percentage by atomic weight will give you the number of moles. So 50 by 32, 50 by 16 will give you 1.56. Here you will get 3.12. The smallest number out of this is 1.56. So divide by that on both sides, you will become 1 and 2. So from this I understood 1 sulfur and 2 mole of oxygen atom. So my empirical formula here is SO2. So it's this type of questions are very simple. You can easily calculate it. Okay. Yeah, this is a very important question. So I also told you how to calculate. I told you I will tell you how to calculate molecular formula. Molecular formula or molecular mass first we need to calculate. How you can find out molecular mass or molecular formula, how we can calculate it. For that you need to calculate molecular mass. This molecular mass should be divided by empirical formula mass. How empirical formula mass you will get? That would be obtained from here. SO2 we can calculate, sulfur 32, oxygen 16 into 2, 32. So oxygen also 32, sulfur also 32. So 64 is the empirical formula mass. They should have given molecular mass. Then only we can calculate molecular formula. So molecular mass divided by empirical formula mass will give you n value. You might have learned while you have learning this n. If you divide, put it here, SO2 with respect to n, then this will become Sn and O become O2n. That is my molecular formula. This is how you need to do it. Just I have told you the idea. Okay, this is another important question from this area. Very important. You can expect this for exam. Please note it down. Okay, the question here is, listen, the number of atoms of chromium and oxygen, they are mentioned. Number of atoms are mentioned. 4.8 into 10 power 10 and 9.6 into 10 power 10. And then they are asking empirical formula. Until now, this like questions haven't came for Neet. That's why I told it's very important. So first, with respect to number of atoms, we need to find out the number of moles of chromium and number of moles of oxygen. Then we can go at empirical formula. Listen, so 6.022 into 10 power 23 or Avogadro number of chromium atoms corresponds to 1 mole of chromium atom. We know it's a fundamental thing. But we have how much? 4.8 into 10 power 10. So how to convert this to this particular number? Divide by this number, Avogadro, and then multiply with this value. So that's why dividing means this will come in the denominator, then multiply with this particular number. That's why it is coming in the numerator. Okay, so you can say divide by Na and multiply by 4.8 into 10 power 10 on both sides. So this will become, you will get the number of moles, 8 into 10 power minus 14. And similarly, Avogadro number of oxygen atoms corresponds to 1 mole. You want to convert this value to 9.6 into 10 power 10. This is the given value. How to do that? Divide by Na, then multiply by 9.6 into 10 power 10. So you will get the respective number of moles of oxygen also. Now you know the number of moles. Take the ratio. 8 into 10 power minus 14, 16 into 10 power minus 14. This will cancel. Then 8 by 16, you are getting 1:2. So actually we are finding out the simplest ratio of chromium and oxygen by other method also. So here 1:2. So then the formula is chromium CrO2 would be the formula. Okay, so there also we did the same thing in the previous question. You are getting the mole ratio and simplest mole ratio we are taking and putting it. Here also the mole ratio is obtained by a different method. That is the only difference. So please remember, when empirical formula they are asking, you are actually finding the mole ratio and simplest mole ratio you are putting it. Okay, so I hope it is clear for you. Next is a question from NCERT. Very important question. You can see here NCERT I have mentioned. Okay, so let's go a little fast. So the question here given here is 10 volume of dihydrogen gas react with 5 volume of dioxygen gas. So you can see here two reactants quantity is given, 10 volume and 5 volume. So limiting reagent can come into picture. How many volume of water vapor would be produced? This is the question. So here hydrogen combining with oxygen to form water. So first write down the equation, H2 plus O2 gives H2O. Then balance it, very important, balance it. Okay, once you have balanced, write down the stoichiometric ratio, or we can do it directly with respect to Avogadro's concept. Stoichiometric ratio you can note it down, 2:1:2. Okay, that is 2 volume of hydrogen combines with 1 volume of oxygen to give 2 volume of water vapor. Now what is given to you? Given to you is 10 liter, 10 volume. You can take the volume as liter, no issues, or even ml also, it's fine. You will get the same answer. So 10 liter hydrogen and 5 liter oxygen. So divide this 10 liter by stoichiometric coefficient, 10 by 2 and this 5 by 1. So which is a smaller number, sir? You can see 5 equal to 5. This is some cases where even though both quantities are given, if these values are equal, then there is no limiting reagent. I told when you are doing it, if there is a lesser number, then that is the limiting reagent. If there is no limiting reagent, you don't need to worry. You can take any of the reactant and find out the respective amount of water vapor formed in the reaction. So if I am taking oxygen, I can say 1 mole oxygen give 2 mole of water. Then with respect to oxygen, how much liter of oxygen is there? 5 liter. So multiply by 5 on both sides, I will get the answer. Or even you can take 2 mole hydrogen gives 2 mole water. Then how much amount of hydrogen is there? 10. So to multiply by 5 on both sides, you will get the respective amount of water. So here I am taking oxygen. So from stoichiometry I know 1 liter oxygen can give you 2 liter of water vapor. Now any doubt? 1 liter oxygen, 1 mole of oxygen gives 2. So I am taking directly in volume. So 1 liter oxygen gives 2 liter of water vapor. Then multiply by 5. Why you are multiplying by 5? Because given to you is 5 liter. But if you are taking hydrogen, given to you is 10 liter. Then respectively you need to multiply. Okay, so 5 liter oxygen multiply by 5, here also 5, you are getting 10 liter water vapor. You can easily say that is 10 volume of water vapor. Okay, so here I have mentioned that important point. If the ratio of the given quantity of the reactants are equal to the stoichiometric ratio, then there will be no limiting reagent. This is another important way to identify. One way is you need to divide this by this one, and if you are getting it equal, there is no limiting reagent. Other easy way is just to check out this number. This is 10 and this is 5. Check this is a multiple of this stoichiometric value. Yes, 2 into 5 is 10. Then this is a direct multiple. And check this is a multiple of this one. 1 into 5 is 5. If these are direct multiples, then also no stoichiometric it will come into picture. No, there will be no limiting reagent. Okay, that is another way. Because why I am telling that is because if you take this 10 is to 5 and cut it down with the smallest 5 here. So if you are 10 is to 5 and divide by 5 on both sides, then this will become 1 is to 2. That is nothing but this value. Okay, if you take the ratio of the given quantity and that ratio is equal to stoichiometric ratio, then also no limiting reagent will come into picture. Okay, now comes the most important question that came for NEET, already came. We have done this previously in our institute. Okay, why it is very important is because here if you read the question, we have some equation, calcium carbonate, and this is a direct question from NCERT. That makes me a little bit happy because this came for NEET and this is directly from exercises of NCERT. Okay, here they have given the calcium carbonate given quantity in like volume and molarity. So many students know number of moles can be found out even if you are given molarity and volume, because the equation is number of molarity is what? Molarity is number of moles divided by volume of the solution. So from this, number of moles is equal to molarity into volume. So please remember, this is another important equation to find out the number of moles. So number of moles is equal to molarity into volume of the solution in liters. So first we do this. So molarity is given as 3/4 and volume is 25 ml, so 25 by 1000. So from this we get the number of moles. Now it is similar. Okay, now it is similar. We know the number of moles of calcium carbonate. Now we need to calculate from stoichiometry. 1 mole will give you 1 mole calcium carbonate. 1 mole, this will give you 1 mole of carbon dioxide. Only this point you need to know. So 1 mole calcium carbonate gives you 2 mole of HCl. They are asking you HCl. Okay, that's the reason why I am talking with respect to HCl. They are asking you what mass of calcium carbonate is required to react with this much amount of HCl. So HCl only we are calculating the number of moles, and with respect to that how much amount of calcium carbonate is required. That's what we are calculating now. So we know from the stoichiometry 1 mole calcium carbonate needs 2 mole of HCl. So tell me, sir, how much amount of HCl you have? We know that 3/160 mole of HCl we have in our hand. So we will first convert this 2 to 1 and then 1 to 3/160. So divide by 2 first on both sides, then multiply by 3/160 on both sides. Correct? So this will become 3/320 ml of calcium carbonate is required. But they are asking the answer not in moles but in mass. We know that 1 mole of calcium carbonate will have a mass weight equal to mass number in grams, that is 100 gram. So 3/320 will have what? Multiply by 3/320 on both sides. So this will become 15/16 gram, or we can say the answer is 0.9375 gram. It will come into picture. It's a very important question that already came for NEET. So the thing I need to focus there is, if number of moles are not mentioned in the question, check whether volume and molarity is mentioned, multiply each other to get the number of moles, then the remaining things are almost the same. Okay. So we go to the last part of this last topics, that is molarity, normality. Even though these topics are explained very clearly in the chapter solutions, they are just introducing you these topics. So that's why we are doing some simple questions from this. The question is, what is the concentration of the sugar in mole per liter? So that means they are asking you molarity. If 20 grams are dissolved in water to make a volume up to 2 liter. So we know that molarity is number of moles by volume of the solution in liters. So number of moles, how you can calculate, sir? Weight, given weight, that is 20 gram by molar mass of C12H22O11, that we calculated as 342. So 20/342 is the number of moles divided by volume in liters, that is volume of the solution, that is 2. So if you do that, you get the answer as 0.029 molar. Okay, very easy question. Now we have our last question. This is also from that particular area. This is like calculate the mass of sodium acetate required to make 500 ml 0.375 molar solution. Molar mass is given. It's also direct NCERT. That's why I have included here. Here they are asking you to find out this W, weight in gram. Molarity is given. Molar mass, it's mentioned 82, and volume of the solution also mentioned as 500 ml. We need to convert this into liters, so it becomes 0.5 liter. Molarity 0.375, weight is what we need to calculate, and 82 is the molar mass of sodium acetate. So from this we can calculate W. It will come around 15.375 gram. So I hope you got a very quick revision for this chapter. Okay, and if you have any doubt, feel free to comment on the comment box. I will be answering you all this. If you have any doubts, you can directly call Brainiacs Classes. Even you can get chapter wise support if you are required. And please understand, you will get all lectures, all live lectures in our Brainiacs YouTube channel. Go to the YouTube, go to Brainiacs Classes, subscribe it and press the bell icon to get the continuous notifications. Daily videos are there, daily teaching videos are there. You can write down the notes. Those students who are preparing at the home, you can completely believe the channel Brainiacs Classes and continue your NEET coaching, and you will get very good score, I'm sure. you are all going to score very good marks for NEET exam and become a very good future doctors for our society. Okay, so thank you. So next Sunday we will come with some other chapters, so please tune to our channel. You are all going to become very great doctors. Thank you. Bye from Riyaz sir. Bye.